Hey guys, so today we're doing Punnett squares step by step. We're looking further into the generations of Sky and Poppy, which is more of their children or offspring, Ocean and Lucy. Ocean and Lucy were in the second generation. So we're leading into Punnett squares, so we're going to kind of look at more of the percentages on what the likelihood of having an orange and blue tail would be. So, as observed, it says the cross between the generation 2, big T, little t, critters, Ocean and Lucy is, and it shows you just some information. So let's go through this. Anytime you see the word cross, you're going to think of similar to multiplication, just as is. If you're really just multiplying the genotypes. Remember, genotypes is a 2-letter combination. So anytime you see any type of letters, you can use any variable. It doesn't have to be T. This is a genotype. Remember, you get one allele from mom, one allele from your dad. So anytime you see a capital T, that's going to be the dominant trait, and that's going to be a blue tail. Okay, we're going to try to color code this as we go. Anytime you see a little t, that's going to represent an orange tail, which is the recessive trait. Also, they are heterozygous because we have a dominant allele and a recessive, or what we call big little. Some also, they're both heterozygous. Remember, the prefix for hetero means different. So you're going to have a dominant and a recessive allele, or what we like to just kind of nickname big little. Now, when we get into these colors, this is stuff that we can see, or characteristics we can see, those human characteristics. So these are going to be the phenotypes. Okay. So now that we have a little background information, let's look at the first word problem. Note that while Ocean and Lucy both have blue tails, they are both heterozygous. Number 1, referring to the example above from your book, complete this Punnett square for the cross between Ocean and Lucy. So again, we're just combining their genotypes. So it's kind of like multiplication or a multiplication table. Anytime you see the word "and" between two individuals or two organisms, always put a little X over it to mean that's what I'm crossing. Also, when I'm doing a Punnett square, whatever comes first, I put on top. So Ocean, I'm going to put on top. Lucy, I'm going to put on the side. However, it does not matter which side of the Punnett square you put it on because you will get the same information. It'll just be a different configuration. So this is Ocean. The genotype was big little. So I'm going to rewrite this on top of my Punnett square. I'm going to put Lucy on the side. Again, we have big little for heterozygous. So it kind of looks like a multiplication table you've seen in math class. So this is a cool way that you can do this. It's more of like a matching game. You're just going to think when you're doing this, it's a matching game. So if I'm starting at the top square right here, I'm going to take whatever is on my left side and the top and combine it. So this will be big T, big T. I'm going to do the same thing to the top right. I'm going to bring over my large T, little t. Now, just as a reminder, when we're doing heterozygous, Remember that we usually write it big, little. In some instances, you can write it little, big. However, we don't really use this one. We like to write it big, little. You'll use the other format when you get into higher level science. But for right now, let's concentrate always putting the big in front of the little. So down here, when we're combining the bottom left, I have a little t I'm going to bring over, and in this column I have my large T. Remember the format, so I'm going to do large, little. Then at the very end I have little, little. So these are all the possible genotypes when you cross Ocean and Lucy. Now remember, Punnett squares are showing us a probability. So this is a chance. So what do we have to do with our Punnett square? It says use either a blue pencil, I'm going to use a blue pen, or a regular pencil to shade in the squares for the offspring with blue tails. Well, remember, the blue tails is that dominant trait. So if that dominant trait is apparent, then it's going to outshine or mask that recessive trait. So you should be shading in. If you see a capital T, it's got to be blue. So this one would be blue because we got 2. This one has at least 1, so I would shade in this square. This one has at least 1, so I would shade in this square. I don't have a dominant trait here, so this one would be orange because it is recessive. So for letter G, it says about what fraction of the offspring. Oh no, some of you don't like fractions. That's okay. They're not my favorite either, but we're going to get through this. Of offspring of Ocean and Lucy are predicted to have blue tails. Well, out of the 4 boxes, 3 of them are shaded. So you could have wrote 3/4. Or we're going to deal with quarters, which are 0, 25, 50, 75, and 100. Well, 3/4 is the same thing as 75%. You can write it either way. So it says about what fraction are going to be orange tails. Well, that should be the remaining square, which is 1/4, or 25%. Always, another way you can check yourself with Punnett squares is the percentages of whatever characteristics. So we had 75 and 25. This should equal 100 when you're doing your percentages. So you can check your work. All right, let's go to another example. So this was Ocean and Lucy, their offspring. So for us, we were looking at generation 3, and this is what we discovered, that the orange tail trait did reappear, and that we do have still a likelihood of blue tails, but that orange trait did reappear. All right, so let's keep going. Now we're going to complete the Punnett square for a cross between an orange tail critter and a heterozygous blue tail critter. Well, in order for it to be an orange tail, it has to be all recessive. So that's how we get the little t, little t. Heterozygous, hetero means big, little, or different. So that's how we get big, little. Sure enough, that's how they set it up. When we get into higher practice with Punnett squares, you won't have these as your guides. You have to come up with these. So again, this was an orange tail. It came first, so I'm going to put it on top. It's recessive. Also, since they're both little, little, they are homozygous. Remember the prefix homo means same, so they have the same type of lettering. That means little, little. Hetero is different. This is going to go on the side because it came second. Big, little. Now, again, it doesn't matter. I could have flip-flopped these, and you could have got the same exact answer. But again, I'll show you how to do that here in a second, what I mean by that. So let's rewrite this and complete the Punnett square. So you have little, little, and you have big, little. I'm just rewriting my genotypes. Now we do our matching game. So big, little. Remember, we always write the dominant trait or the big out front. Top right, big, little. Then we have little, little. Then little, little. So again, we're going to look at the options we have to do. It says use a pencil to shade in the squares with blue. Remember, if it's blue, it has to be a capital T, or has to have at least one of those alleles. So I'm going to shade in this one. It has a capital T and the one right beside it. Part B, what fraction of the offspring are predicted to have blue tails? Well, that's 2 out of 4 squares, or 50%, whichever way you would like to write it. Then it's asking what fraction are predicted to have orange tails. Well, I know it didn't say shade it, but I'm going to just do it to help with the visual. So for orange tails, remember that is little t, or homozygous recessive, and you get 2/4 or 50%. Now, some of you might be wondering, why did I say you could redo this a different way and get the same exact answer? Well, I'm going to show you real quickly. Instead of writing this on top, I wrote it on the side. What I had over here on the side, I put on top. So I'm just kind of going through these real quick. So here you do big, little, 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 big, little, little, little. And sure enough, you get the same exact answers. They're just in a different configuration. However, for consistency, I usually, like I said earlier, I put whatever's first in the problem on top, whatever's second in the problem, I put on the side. But you can do it, it doesn't really matter what order you go in. All right. So good job, y'all. You're doing great. All right, last one. It says complete this Punnett square of a cross between a heterozygous blue tail, which is big, big. Now, wait a minute. They did a typo. Shamefulness. They said heterozygous. It shouldn't be heterozygous. It should be homozygous. Because if you look, you have big, big. So they have the same here. So this should not be heterozygous. This should be homozygous. Look at those science people making mistakes. And they're both capital, so this would be dominant. So that would go on top. And a heterozygous, which means different. I'm trying to review some of your vocab. Blue tail critter. Remember different? That means big, little. And this would go on the side. And sure enough, just mark that out so you don't do heterozygous. So again, we just rewrite our genotypes to go on top of inside of our Punnett square. You got big, 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 little. Now we do our matching game. Big, 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 little. Now remember, we always write our dominant in the front. Our big always has to go in the front. And then over here, again, you get big, little. All right. It says use a pencil. We're going to shade in our boxes for blue, Remember, blue has to have at least one dominant trait. Well, this has two, so this one's definitely dominant. This one has two, so this is definitely dominant. This one has two. Well, sorry, this one has one, but since it has one in it, you shade it because it would be blue. This one has one dominant T, so we would call this one blue. Because remember, the dominant trait outshines the recessive. So about what fraction of the offspring would be predicted to be blue tails? Well, technically all of them. So that'd be 4 out of 4, which some of you would be like, well, that's a whole or 1. Well, then that would be 100%. So what fraction would predict to be orange tails? Well, we don't have any in this one, which that can happen. So that'd be 0 out of 4 or 0%. Yes, on some of these you can get 0%. All right, y'all, so we're going to start diving into some Punnett squares.